Hey everybody, welcome to the Geo Shed. This is going to be a two-part episode, I think. What I am going to be talking about is I am going to be critiquing a short film made by Eric Hovind called Scarred Earth. I am not going to include any clips from that movie in here, as I do not want copyright strikes, but I did take copious notes. I've already gone through this with Apologia, and I'll link that video below as well. But I need to stress something here. I am not bashing anyone's religion when I do this or their beliefs. I am doing what I need to do. I am calling out pseudoscience. And this video, Scarred Earth, is one large pile of steaming pseudoscience. Eric Hovind is a great salesman, I'll give him that, all right? And there's a couple other people he mentioned, or that are in the video. There is Russ Miller and Adam Huff. Neither of them are geologists, neither of them are scientists, neither of them have a degree in any earth science, and you don't need to have a degree to understand geology or earth science. But if you're going to sit there and present a video as fact and put people up as authorities and knowledgeable, it might behoove them to actually have a background in what they're talking about. All right, watch the video if you want. It is available here on this website. All right, the first 15 minutes or first 16 minutes I'm going to deal with. The rest of the video is just Eric making you feel guilty about not believing what he does and then trying to get money from you. So we're just going to leave that. I'm not going to touch that part. All right. You know, if that's your faith, whatever, fine. But I will deal with the pseudoscience being presented as actual science in this video. So why am I even dealing with this? Why do I even care? Well, because there's a lot of misinformation in this video that Eric Hovind put out. There is a distinct confusion, and I figured it out. There's a lot of word salad here, and Hovind does this intentionally, like erosion marks, which I'm going to talk about. He does this intentionally, occasionally sticking legitimate terms within it, but as a professional watching it, it confused the crap out of me. All right, because I actually know this stuff. And I finally figured out what it is. He's trying to confuse betting and unconformities, and I'll get into that in detail. And that's what the title of this video has to do with, unconformities. I'm going to explain the difference to you after I go through some points in Hovind's video. The second part of this, part 2, is going to be the Baraboo area. I'm going to take you up to Wisconsin, south central Wisconsin, to the Baraboo area, to the Baraboo quartzite, and I am going to show you some field unconformities. So that'll be the second part, and that's the last I'm going to say about Baraboo for right now. But first I got to deal with this Grand Canyon video. Before I get into my slides that I have prepared, I'm going to talk about specific things within this Scarred Earth video. All right? And I'm going to give quick approximate times, plus or minus 5 to 10 seconds. You can find them in the video if you want. Like I said, I didn't take clips from it, okay? First of all, at about 43 seconds, Hovind asks, and this is a direct quote, "Are you open to scientific evidence that the Grand Canyon, formed from a catastrophic event?" He uses the two words, scientific evidence, and provides none of this. All right. And when you are sitting there trying to falsify a scientific concept, you do not sit there, make a claim, and then jump to a conclusion. You need this whole thing in between. You need to present your evidence so that others can test it. If you're just starting at a claim and jumping to a conclusion, you're not doing science. That crap might work in philosophy and arguments, but in science, arguments don't mean anything. They're a starting point. They aren't evidence of anything. And there is no scientific evidence of anything in this video. Nothing is cited, nothing is sourced. Later, towards the end, there is a very generic, zoomed out model of how they think the Grand Canyon formed. I'm going to get into that too. I'm going to use my own interpretation of their model because they never really present a testable model, and young Earth creationists like Hovind never do. It's because they don't want you to be able to test it, because if you can test it, you can falsify it. So, but their model, it has no scale, right? It has none of the geologic units labeled, right? It's just basically this is how we think the canyon formed. It's poor. And I understand when you're doing a documentary, you need to be visual. And I'm going to clutter this with papers and citations and slides and stuff. So this isn't going to be very visually appealing, obviously, unless you like black cat calendars. But anyway, when you are sitting there presenting something like this, presenting something as an alternative hypothesis to well-established scientific reasoning and evidence, you need to sit there and put forth something somebody can look at, test themselves, confirm or refute, falsify or verify. All right? You can't just do this, you just drop down a bunch of claims and jump to a conclusion, because that is not science. I don't know how many times I have to tell people this, but that is in no way, shape, or form how you do science. That is not the scientific method at all. If I remember, I will link my scientific method video below too, where I explain that. In Hovind's Scarred Earth, he interviews a bunch of people, and I'm sure he cherry-picked the ones that gave him a favorable answer. Sought what he was looking for, but the opinions of the general public, especially if they are not knowledgeable in something, is not relevant to anything. Okay? It definitely isn't science, all right? And it's kind of a crappy thing to do to people who don't have a base knowledge to work from. Okay, here at about 3 minutes and 30 seconds, Hovind says, and I quote, "The walls of the canyon are sheer cliffs, yet they are made of sediments that would not hold up over long periods of time." That is a statement pulled from his backside. All right? The walls of the canyon, you basically have, in a nutshell, and I'm going to get into this in more detail, is you have a crystalline, metamorphic, and igneous basement called the Venetian group. Okay? Above that, which Hovind completely ignores, and everyone else in the video, is something called the Grand Canyon supergroup, which is a sedimentary and igneous package of rocks that is all Precambrian, which I'll get into in a little bit too. And above that, you basically have the Phanerozoic sequence from the beginning of the Cambrian to the present day. Okay? He gives this impression as if you could just go in, grab the walls of the canyon, and pull out clumps of sediment, as if it's not indurated, as if it's not rock, just loose sediment. That is totally untrue. I would like for him to go down to the Venetian and try to stick his hand and dig out a piece of that metamorphic crystal and rock and watch how well that goes for him, because that's just a false statement. Now I'm going to get into Russ Miller, okay? Apparently Russ, according to creationministries.org, completed 174 college credits but never earned a degree. It doesn't say in what. Apparently he's a speaker. Well, being somebody who can communicate effectively doesn't mean your ass from a hole in the ground when it comes to certain things. He's not an expert, all right? At about 7 minutes and 17 seconds, enter Adam Huff. And he either runs, there's a part of this thing called a Different View Tours. That right there should send up red flags. He doesn't know anything about geology. He is not a scientist. He is not an engineer. He is not an expert on the Grand Canyon. He's a guy running a business. Okay? I just want to say again, I'm not bashing people who didn't go to college, but when you're trying to present yourself as a scientific authority, you better have a science background. But he, about 10 seconds after that, starts talking about the Tapeats sandstone. This is a basal Cambrian unit in the Grand Canyon, which I'm going to get into more in a little bit here, okay? But he makes the claim that the Tapeats layer covers 70% of the United States. He says you can find the Tapeats up into Canada. And then he says some are local, some are regional, some are global. implying that the Tapeats is a global deposit. It is not. It isn't even consistent in the Grand Canyon. It's missing within the Grand Canyon in places, which I'm going to show you in a little bit. What he is calling the Tapeat sandstone in lithostratigraphy, when we formally designate geologic formations, we designate them by their lithology, the characteristics of the rock. They are independent of time, but we can correlate them, and that's a talk for another time. But when he says the Tapeat sandstone covers 70% of the U.S., it does not. There is no Tapeat sandstone in the Upper Peninsula of Michigan. It's the Munising Formation. Because up in the Midwest, we don't have early Cambrian deposits. That's another thing, which I'll get into, the 60-mile formation, which we now know is Cambrian. That's in the Grand Canyon. We used to think that was pre-Cambrian. But so in the Midwest here, we don't have any early Cambrian deposits. So we don't really have anything that correlates with like the 60-mile formation, okay? So, and then in Baraboo, you have like the Wanawak formation. You have several Cambrian formations in Wanawak, which has the Galesville member in it, and I'm going to talk about that in a little bit too when I get to Baraboo. So we do not name these units the same thing because we think they're about the same age. They have to be lithologically similar. See, it's not the simple, oh yeah, there's a bunch of sand at the base of the Cambrian around the world. It's not that simple. And that's the picture they're portraying here. And that is a misconception, okay? At about 7 minutes, 55 seconds, Adam sits there and makes the statement. I'm paraphrasing here. I didn't write down the exact quote, but it's close. There, meaning the strata, the geologic formations, are like a big old stack of pancakes. One, and even does this, one on top of another. That is a very gross oversimplification of what is going on in the Grand Canyon. And of course, I'm going to explain to you why. It seems that Eric Hovind and crew prescribe to the old base of the Cambrian as being the bottom of the Great Flood deposits. Okay, and I'm going to talk about this a little more in a few minutes. That was an idea that came about in 1961. Here's the citation. That was first proposed then. But like I've said before, there's a whole stack of Precambrian sediments below it that aren't even mentioned. Wonder why that is. Continued from that 7 minute 55 second mark. Where one touches the one beneath it, he's talking about individual beds, and it took me a while to figure that out, okay? But all right, where one touches the one beneath it is a very flat contact point, very smooth. No sign of any erosion. No sign of any vegetation growing on it. You have to conclude that one large catastrophic event laid all this down quickly and buried a lot of animals in the process. I have to agree with the flood model. Unquote. Number one, there is no flood model. If there was a flood model, we'd be able to test it. There's at least no scientific flood model, okay? Like I said, a bunch of statements aren't a model, all right? That right there, at first I thought he was talking about the Great Unconformity, which I'm going to elaborate on. There's actually two in the Grand Canyon. But from the picture they showed, I don't know where it was from, it looked like individual beds, okay? And this is the key point of them trying to muddy the waters to confuse you. It confused me. And I know this stuff, okay? And I think I got confused because it was so muddied and vague that I didn't know where they were leaning. Were they talking about the Great Unconformity? Were they talking about bedding planes? Well, I figured out they're trying to merge the two into one thing, okay? I'm just going to address this real quick right now. When he said the part about no sign of any erosion, I'm going to talk more about beds here in a few minutes. Actually, you know what? I'll do it now. This is a picture of me touching the Apakuni Formation at Glacier National Park. There's the location. See, that's another thing in science. You need to be able to, someone else needs to be able to verify your observations in the field. So it helps to put things like actual locations and not, well, somewhere over there. But anyway, what you see here, these yellow lines, are bedding planes. I think this is what he was addressing, but I don't think he understands what's going on. Surprise, okay? Now, these are pretty level flat-lying bedding plains within the Apicuni Formation, which is Mesoproterozoic, which is Precambrian. Precambrian is a term we as geologists have kind of abandoned. It's not a legitimate term, but everyone's so familiar with it that I'm going to say it here. The Mesoproterozoic is about, 1,600 million to 1,000 million years ago. Okay? But in the picture, they look undulating, and they are a little bit, but that's just the effect of, 3 dimensions being translated into 2. So here, you see, bedding plains are primary sedimentary structures on top of strata that separate the above and below strata. Okay? That's what a bedding plain is. Well, that doesn't really tell me what their characteristics on the plane are, because this is a cross-sectional view. Well, the surfaces of bedding plains, they can be smooth, pitted, mud-cracked, or rippled. I'm only going to address those ones. There's others, but I don't want this to become a structural geology lesson. Bedding plains can be formed by a hiatus in deposition, non-deposition, a change in grain size, a change in sedimentary type, or a sudden change in sedimentary environment. And I'm going to come back to that part. But bedding plains are not necessarily unconformities. They can represent a little bit of missing time. But how much time is actually missing? That's the thing. In geology, a bedding plain could be several minutes of missing time. It could be 1,000 years. There's no way to really know that. That's not knowable. So we generally don't treat them as unconformities. I'm going to get into the types of unconformities in a little bit. If there's a hiatus in deposition or non-deposition, that would be technically an unconformity. But like I said, it doesn't have to be that. You could have a change in grain size can mark a bed. Like you could get an influx of coarser sand or more shale, and that'll form a distinct bed. A change in sediment type. You can completely switch from a sandstone to a shale. There's no unconformity there. It's just a change in sedimentation type. Or a sudden change in sedimentary environment. And I'm going to kind of get into that when I get into unconformities and what causes them. But like a storm or volcanic eruption, that can interrupt sedimentation really quick. Those things, all right? And so can an asteroid impact. So a bedding plain does not necessarily represent an unconformity. And if it does, it doesn't necessarily represent a knowable amount of missing time, because an unconformity, that's what it is. It's a bit of missing time in a geologic succession, okay? That's what it is. You basically have 3 types of unconformities. And I've done videos on this, Geo-Rant 102 and 103, part 1 and 2, go into great detail on this, so I'm only going to touch upon this here. They'll be linked below if you want to watch them. You have a disconformity, a nonconformity, and an angular unconformity. I'm going to talk about a buttress unconformity, which is a type of angular unconformity. The 3 main types have others that are within them. And basically a buttress unconformity, because you're going to see this here, is younger beds are adjacent to older beds, influencing the structure of younger beds, usually in the form of initial dip. What does that mean? Okay, that means as erosion takes place, paleotopography develops, and then sedimentation can begin, and instead of getting level beds like you would far out in a marine sequence, they might have some initial dip to it, and we're actually going to see that in place when I get to the Baraboo video. All right, we're also going to see it a little bit here in the Grand Canyon as well. So, but unconformities are recognized, they have to be recognizable in the field. There are other ways you can recognize unconformities, like if you have a drill core and you could, paleomagnetism is a way to do it, through geochemistry. But generally, if it's not recognizable in the field, there's no unconformity, all right? You have to be able to identify these things. Like angular unconformities are obvious. Disconformities and nonconformities, depending on what they are, a little different. But unconformities are observations in the field. They are spotted in the field by how they relate to the surrounding strata, either above, below, to the left, or to the right. How they form does not define what type of unconformity they are, because that can cross unconformities. Like you have a disconformity, nonconformity, angular unconformity. Those 3 main types can be formed, like erosion can form an angular unconformity or even a disconformity. Okay, so the causes don't have anything to do with it. When you're identifying strata in the field, you try to keep the interpretation out of your actual description. You will develop a stratigraphic column. Now, this is something that young Earth creationists also tried to muddy the waters with by something called a geologic column. They use that term. That's not a term we really use. It's a mix-mash of terms. It's a geologic time scale, and they drop the time scale part, and they take the stratigraphic column, drop the strat part, and you get geologic column. They're mashing it too. And often on geologic maps and papers, the two will appear side by side, but they're technically not the same thing. It's not really a term we use. We can recognize unconformities in the field, and we have those three main types, all right? But what causes them? Well, I'm only going to touch on about 4 here, because I get into more detail in my other videos on unconformities. We basically have the big one, is erosion. And we're going to come back to this again and again. You get a bunch of deposits, a sedimentary rock sequence, and then if it's exposed to the surface or even subaerial, we'll assume it's exposed to the surface. You have rock strata. Erosion, obviously, in time will wear it down unevenly. As a matter of fact, I am standing on an unconformity in the making. See what I'm standing on here? See it? I'm walking on. I'm standing on an unconformity right here. An unconformity in the making. I'm standing on 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 a conformity in the making. Now, that last one was at Medora Lake. That was a conformity in the making. And I'm going to touch into why that is here in a second, but the water is really cold. Maybe 5 degrees Celsius, which is what? 40 degrees Fahrenheit. Where there's active deposition, you have a conformity. You know, it might stop for a minute or an hour or whatever, but it doesn't matter because you can't recognize that. All right? And generally in lake and marine environments, you have continuous deposition. Generally, there are exceptions. And that's why I stood in Lake Medora there and said that was a conformity in the making, just to show you that. But standing here on dry land, it's unconformities in the making. So I don't know why this concept is so hard to understand. Now, why isn't it an actual unconformity? Because nothing has been deposited on top of me yet. So there's still more erosion to take place before that. That's a big one. The next one is non-deposition, and I've talked about that. That could just be, you get, say you're getting sand coming in, all of a sudden that stops. Your source is near lake level or sea level, so it's not really eroding anymore. So you get a period of non-deposition, all right? And then maybe carbonates might get deposited on top of them. That's one way, that's a type of unconformity that is a disconformity. And those can be sometimes really hard to recognize, but they can also form things like hard grounds, because in carbonates, if there's a hiatus, what will happen is a lot of the times that carbonate will get redissolved into the water. And being subaerially exposed, it'll get pitted out, and different minerals may even come in and interact with that surface layer. So those are a little easier to spot. Then you can get intrusions. An igneous intrusion comes in through your deposits, and the edge of that intrusion with whatever layer you have over here, that's your unconformity. And impacts. Meteor comes in, makes a big hole in the ground, asteroid, whatever. Faults are not unconformities. I addressed that in my unconformity video, so I'm not going to touch on it here. They are a type of contact, faults are. And so are unconformities. But faults are not unconformities. And young Earth creationists love the Grand Canyon for some reason, but when you actually look at it closely and actually, study it, it comes really clear that the Grand Canyon, they see a big hole in the ground, they go, flood did it. But they ignore the walls themselves that make up the canyon. That strata is important. At 13 minutes, Hovind goes through several of what he says are scientific facts, but they're really just unfounded claims. He just sits there, he says, he numbers 1, 2, and 3 with his fingers. But there's a little more after that, but he stops numbering them after 3. 1310, his fact number 2. This one burns geologists, and he wears his ignorance on his sleeve here. He says a mile of dirt. He says dirt, not once, not twice, but 3 times, within a 30-second period. All right? And then he says it another time at 15 minutes and 40 seconds. So he says it a total of 4 times when he says a mile of dirt has been removed above what is presently the top of the canyon walls. No geologist says dirt. You don't refer to strata as dirt. That right there just shows you have no idea what you're talking about. Okay? And you're either poking fun at the field of geology or you're just ignorant to the nth degree. So pick whichever one. I'm not going to judge which one it is. At 1330, his fact number 3, he says erosion marks. This is word salad, and this adds to the confusion. There is no such thing as an erosion mark. Like I've just addressed geologic column, which is kind of a mishmash, geologic timescale, and stratigraphic column. Erosion marks is total word salad. It means nothing. He doesn't identify it or define it anywhere in the video. He just says it, okay? Because it sounds like, to somebody who doesn't know anything about geology and earth science, that might be a legitimate term, and it's not. No one uses that. It doesn't mean anything. Erosion mark. I don't know. I mean, I'm standing on an unconformity in the making, so erosion is taking place. I mean, what is an erosion mark? Am I scratching it with a pair of scissors? It doesn't mean anything. And of course he doesn't define it. So it's word salad. And then he goes on to say no growth of root structures in the layers. Of course not. The Tepete sandstone is Cambrian, Ordovician, Silurian, Devonian periods. Up here, I don't know why you would expect to see roots growing in sediments when they hadn't evolved yet. All right? But there's Precambrian sedimentary deposits, and some of those could be terrestrial lakes, and there's no roots in any of those. The only fossils in those are stromatolites and algae mats. That's it. All right? Why? Because plants with roots didn't exist then. So that doesn't mean anything either. It sounds good if you don't know anything about the evolution of plants, or anything about the rock record or geology or anything like that. Now what I'm going to do is I'm going to show you a series of slides and basically show you how everything he said was a pile of steaming garbage. But first, I'm going to talk about the young earth creationist model of how the Grand Canyon formed. In the video, there's some very zoomed out animation of how they think the canyon formed, with no legend, no scale, nothing. Okay? So it's hard to piece together what their model is, and there's a reason for that. It's so you can't test it, and it makes it harder to refute. The Eric Hovind model of how the Grand Canyon formed from the rhetoric in the video, it basically, I think, can be summed up using these slides. I'm going to get great detail of the Grand Canyon and the stratigraphy. Well, not too much detail, but enough to show you that this is BS. All right, this is not the scale. Here, apparently, there was some pre-existing strata, the Vishnu and Grand Canyon supergroups, which he doesn't talk about. All right, there's reasons for that. Okay, well, the Vishnu would be the basement rock, that's your metamorphic and igneous rocks, and the overlying Grand Canyon supergroup really throws a wrench in the whole young earth creationist thing. So then after that, apparently the global flood comes along. All right, so we get the Tepete sandstone above that. That was what Adam was talking about. Okay, and that's the yellowish color in here. And then above that, with the light purple, you get 9 more layers of sediments, because Adam actually does say that in the video. He says at 725, 10 layers, approximately 4,000 feet thick total between the 10 layers to include the Tepetes, filled with fossils. All right, he says that. He's talking about the Paleozoic succession of rocks filled with fossils. Yeah, and they show a history of evolution, which is kind of weird. It's not like we find trilobites next to dinosaur bones. But anyway, that's talk for another time. So that's why I have 9 more layers of sediments on top of it, because I already included the Tepetes. And notice it's very level and flat looking everything is here, because that's the point they try to stress in the video. And then above it we have Hovind's another mile of dirt. Ugh, God, that burns me. And that's the green color. It's strata. Only a fool talks about strata by calling it dirt, all right? So the global flood recedes. So I guess this ancestral Colorado River or huge braided stream system starts cutting down into the mile of dirt as the flood waters recede towards the Gulf of California. And erosion continues. The big river shrinks as it downcuts more into the 9 more layers of sediments, ultimately before forming what we see today, which is the tiny Colorado River down through the Venetian and Grand Canyon supergroups, and our top green layer is now gone. The entire another mile of dirt has been eroded, because in the video he talks a lot about, throws a lot of numbers, volumes of sediment removed from the canyon, and that's a topic for another video I plan on doing, but that doesn't mean anything. Those numbers don't mean anything, and I don't know where he got them from. Assuming they're even calculated correctly, they don't mean anything, but that video will be later. Okay, so that's what I gathered for the video, what Eric Hovind's concept of how the Grand Canyon formed in, and of Russ's and of Adams, and that is a totally inaccurate and very grossly oversimplified concept of what the geologic strata in the Grand Canyon have to show us. Okay, enough of calling out Hovind and crew. It's time to get into some actual geology of the Grand Canyon. It is not a simple layer cake. This layer begat that layer, and so forth, as presented in Scarred Earth. It is far more complex than that, okay? And this here is it's not really a stratigraphic column, it's more of a generalized cross-section through the canyon. It's not to scale at all, and I'm going to get into this, but whenever I present something like this, if it's not my own work, you are going to see a citation on the slide, like here in the upper right-hand corner. This is the Arizona Geological Survey's Open File Report OFR 19-02. Okay, that's where I got this from. And you can see here that the blue-colored rock here represents the Paleozoic. It is greatly exaggerated in this cross-section. The orange-brown color is the Venetian group. That's that basal crystalline igneous and metamorphic complex. And this light purple part here, that's what we're going to focus on a little bit. That's the Grand Canyon supergroup. That is very important and totally overlooked by Hovind and crew. So there are other things here. You see the yellows. We're not going to get into that. Those are more recent volcanic deposits. That is something else not mentioned at all in Hovind's video. It's not the Grand Canyon. The layers in the Grand Canyon are not strictly sedimentary. There are igneous units within it. That's not even mentioned by him. But anyway, the Paleozoic strata are about 900 to 1,200 meters thick. The Grand Canyon, and that's a typical thickness in the canyon. The Grand Canyon supergroup, where not faulted out and complete, is about 3,600 meters thick. Okay, the Grand Canyon supergroup is about 3 times thicker, almost exactly 3 times thicker than the entire Paleozoic succession in the Grand Canyon, and it's totally ignored by young Earth creationists. And it's mostly sedimentary, metasedimentary rock. There are some volcanics. And this is part of the Precambrian. These rocks are, I believe, pretty much Mesoproterozoic and in age. So they're not the most recent Precambrian rocks. What you see here is you will see a bunch of unconformities. And I'm going to talk more about those later here, but there's 2 unconformities blatantly visible in this cross-section. You have the first great unconformity. Yes, there's 2 great unconformities within the Grand Canyon. The first one is recognized where the Grand Canyon supergroup lies directly on top of the Venetian group. The second great unconformity is the one most people think of when they talk about the great unconformity. It's between the Precambrian and the Cambrian and the Paleozoic, or whatever is above it. That is the second one. And you can see here that in some places the second one is present, the first is not. So it's just referred to as the second great unconformity by the Arizona Geological Survey. That is something never mentioned in any of these young Earth creationist videos I've ever seen or heard or read about. So those are the two biggest unconformities, but those aren't the only ones. Surprisingly, there's a lot more. Those are just the two largest. So there's the two largest unconformities within the park. You also see a big fault here. The fault here is just within to show you that in a lot of places the Grand Canyon supergroup is faulted out, but faults propagate the canyon. You're going to see them in a cross section from the canyon, and they are all the way through the stratigraphic units in the canyon. They're not restricted to the Precambrian, okay? Like I said, this is a generalized cross section. So also in the same report, there are pictures, and this one I selected in particular because this shows you, this is an actual picture, the cover image, it's the cover image, and it tells you where it was taken from. Now there are some things you see here. First of all, you see the Venishu basement, all right, that's circled in green. You see the Grand Canyon supergroup, that's that green arrow there, and Grand Canyon supergroup written in green. And in yellow, you see the first great unconformity, which here is about 500 million years of missing time represented. Now, that unconformity, does that look level and flat-lying to you? Granted, this is a picture of this is a two-dimensional picture of a three-dimensional object, but you can plainly see, even in this photo, that the great unconformity expresses what we call paleotopography. As things erode, you can tell just by going around wherever you go. When you drive over a road, you come up over a hill, that's topography that's formed by erosion. You have, and buried topography like this would be called paleotopography. And that is present in the Grand Canyon, and there is also a big fault here in this photo as well that cuts up through the Venishu and the Grand Canyon supergroup, the Cardenas lava sill. And that's been dated at about 1.2 billion years, 1.201. And that is an igneous sill. That is not sedimentary. It was intruded into the Grand Canyon supergroup. All right, so we have igneous rock. We have things that are directly datable within this Grand Canyon supergroup, and we also have them within younger units as well. Okay, so you keep hearing me say unconformities, unconformities, unconformities. I've showed you the first great unconformity and the second great unconformity within the Grand Canyon. Conformities, as I showed you by my standing in places where an unconformity was in the making and a conformity was in the making, that these things do not continue forever. Conformities do not continue forever. Unconformities do not continue forever. And sometimes unconformities can merge. All right? It all depends on the geologic history of the area. And to simply attribute such complex geology to a single event is childlike and naive in its very premise. Okay? But I want to talk more about the unconformities within the Precambrian at the Grand Canyon. What you're looking at here is the geologic timeline of the Grand Canyon. And on the lower right, you can see the Arizona Geological Survey publication that it is in. And I am just going to highlight some things for you here because it's way complicated, all right? What you see here are a bunch of numbers, yellow background, red circle. These are all the recognized unconformities within the Grand Canyon. And there are 11 of them. There are 2 big ones, and then there's 9 smaller ones. All right, and here I've numbered them from the oldest starting at 1 to the youngest being 11. Now what you see here, this green arrow, that is pointing at what we call the 60-mile formation. The top of that used to be where the second great unconformity was, the line was put. There is an unconformity there, but it's not really the great unconformity. On this diagram, it is labeled that way, but you can argue, I mean, this is a nomenclature thing, it's a potato thing, really. But the 60-mile formations, the tridal zircons have been pulled, and we know now that that is Cambrian. It is not Precambrian, late Precambrian, Neoproterozoic, like we originally thought it was. But it is bounded above and below by an unconformity. The arguably, number 10 represents the second great unconformity, not number 11 anymore. And it's just kind of like they just kind of kept it there, even though it's younger than previously thought. You should knock it down. Like I said, there is an unconformity there, but it's not the great unconformity. But that's just my opinion on that nomenclature matter. But what I wanted to show you here with this here is that there are many unconformities recognized within just the Precambrian alone in the Grand Canyon. So I keep saying great unconformity, great unconformity. What is a great unconformity? Well, originally, it was thought as recognized numerous places around the world that between what they called the old primary rocks, which later became Precambrian, we had primary, secondary, tertiary, and quaternary. Okay, and the only one that's still used is quaternary. But the old primary, which would be recognized later as a Precambrian, and the old secondary, which would basically be the Paleozoic and Mesozoic of today, there was a real big unconformity recognized numerous places all over the world. And this became known, it was first recognized in the Grand Canyon, and it became known as the Great Unconformity. Right, and later it would be discovered there was another great, but there's great unconformities within the Precambrian. The Precambrian represents over 88% of Earth's history. It's a huge chunk of time. So logically, if there's big unconformities between the Precambrian and the Cambrian, there's going to be ones within the Precambrian, and that's what that first great unconformity is. Well, what is a great unconformity? Basically, locally, it's the biggest unconformity in the area, or regionally. That's what it really is. Like I said, it was originally recognized between the Precambrian and the Cambrian, between the primary and secondary. But our knowledge has increased, and we know that the Precambrian is a lot larger, represents much larger span of time. Back in the 19th century, they kind of thought that the Precambrian might represent as much time as maybe the Paleozoic. Well, they were really wrong about that. But, new knowledge, you gain knowledge, you change your ideas. That's how science is supposed to work. You're supposed to change your ideas, your concepts, and what you believe based on the evidence. You don't change the evidence to fit your beliefs. And that's a key difference between science and pseudoscience. But is there any place in the world where the great unconformity between the Precambrian and the Cambrian does not exist? Remember how I said conformities do not continue forever and unconformities do not continue forever? Well, there is such a place. One such place is represented in this paper. Don't worry, you're going to get to see a close-up of it. Here's the actual figure in print. What you're looking at in the paper, there's the title. I'm not going to read it for time's sake here. You have Table 3 here, which is a proposed lithostratigraphic correlation, okay? Now, what you see here, all right, what I want to point out to you is you see the chronological time. Now, remember, time is continuous, okay? So even though the rocks may not preserve the time between the Precambrian and the Cambrian, the time that it took still was continuing. So we put a line there. Okay, and that line between the Precambrian and the Cambrian, and the youngest era of the Precambrian is called the Neoproterozoic. So the line between the Neoproterozoic and the Cambrian is 541 million years ago, MA. That's what MA means. If you see GA, that means billions with a B, years ago. So this location here in Argentina shows continuous deposition between the Neoproterozoic and the Cambrian. There is no great unconformity. There is no unconformity whatsoever. You have the Puncoviscana formation, which is highlighted here in yellow. Now remember, lithostratigraphy, they're independent of time. They're based on rock physical characteristics of the rock. So even though you may have progressed through different geologic periods or eras or whatever, the rock being deposited might be the same. So it's the same unit. It's the same formation. Okay? So we had continuous sedimentation between the Neoproterozoic and the Cambrian. And it was roughly deposited between 700 million and 535 million years ago. All right? So it crosses that Precambrian-Cambrian line. All right? Now, there is an unconformity here. It's at the base of the Punkaviskana Formation. I apologize if I'm butchering that word. It's at the base there at about the 700 million years. So there's an unconformity at the base of it, but not at the top of it. So there are places in the world where there is no great unconformity between the Precambrian and the Cambrian. So between the Neoproterozoic and the Paleozoic, which would be the Cambrian's the oldest period of the Paleozoic era. So we do have real-world examples of continuous deposition. So this concept of the great unconformity as being global, when I say global, I mean 100% global, is poppycock. It doesn't exist everywhere. Argentina is one such example. All right, let's get back to the Grand Canyon. I wanted to just show you a real-world example of where there is no great unconformity. Okay? So what you see here, these are photos taken at the website in the lower left-hand corner by Marley Miller. She is an instructor at the University of Oregon, okay? These pictures, she takes some beautiful pictures of the Grand Canyon. If you want, go to her website, it's right there. And she says you can use them for instructional purposes. That's the boxed part I put here from the actual screenshot of the website. And I think this qualifies as that. So I'm going to use two of her photos. Here, the first photo here, which you're looking at, this is the second great unconformity. And it's somewhere along the New Hands Trail. Apparently this is not a very well-traveled trail, but it's very interesting because of what's here. And what you notice about the second great unconformity here, which is solid black, thick line, I've used to highlight it, is that it is definitely not level and flat. Matter of fact, you can see this knob type thing. I'm going to get into that here. We'll ignore the picture in the lower right for a second. So what you have here is you have in yellow, Precambrian Grand Canyon supergroup, the youngest formation at this outcrop, which is the Shinumu quartzite. And above that, you have the blue Paleozoic couple formations of the Tonto group. Now, these are the two I know are in the photo. That high cliff in the far distance in the top kind of center is probably the Mauve limestone, but I don't know that for sure because it wasn't said, so I'm going to leave that out. But you see the Tapete sandstone, and you see the Bright Angel shale. And what do you notice about the Tapetes against the quartzite? You notice the Tapetes pinches out against the Grand Canyon supergroup rocks. That is a buttress unconformity in the field. And we are actually going to see another buttress unconformity, just not this well exposed, at Baraboo. All right. So what happens is you had highly developed paleotopography. So you had terrestrial erosion taking place and the Cambrian seas moved in. And this is going to be a very similar story for Baraboo. All right. So the Cambrian seas moved in, and there would be high areas that stuck up above the water until they became drowned, and deposits would be shed around these high areas. And the buttress unconformity is that knob in the photo. And that was high ground. So the Tapetes pinched out against it because it was really high, and then when the shale got deposited, the shale encompassed it. And eventually became subsequently buried as the Sauk Seas, which are pretty much the Cambrian Ordovician seas, that's what we call them, transgressed across the continent. But they didn't transgress everywhere over the continent. They didn't cover the entire continent of North America, just a large portion of it. All right? So that right there shows you that the great unconformity is not level and flat everywhere. And what you see here in this last slide here is you see I put some dashed lines in there. Those represent bedding. Not every bed is highlighted, but I've already talked about beds. But you can see there that the beds butt up at different angles to one another. This is what we call an angular unconformity. This buttress unconformity is a subset of an angular unconformity. It's a type of angular unconformity in this case. So this layer cake perception given by Hovind in Scarred Earth. You're already seeing it doesn't hold up, even in basic exploration of the canyon. Now this bottom picture, this is the Bass Limestone. This is the basal formation of the Grand Canyon supergroup. And I just like this here because it's cool because it shows something unique. The Bass is mostly a carbonate, but here locally, this is a lens of sandstone, but at the base of it, it contains clasts of carbonate. Now, what that suggests to us is, so on top of the first great unconformity, well, I don't know exactly where this is within the Bass. It may not be right at the bottom. It could be in the middle or whatever. There's also nothing for scale, but by the looks of it, I guess that photos maybe represents a meter in width, okay? But you have incorporated into the sand the underlying carbonate algae. Now, this is suspected to be a storm rip-up. Now, in a violent flooding type event where waves come in and they're crashing against the shore and stuff, you rip things up. And they get deposited and then covered as the storm ends by whatever sediment settles out of the sea in calmer seas. That type of thing, if we were to make a prediction about a global flood occurring within a 1-year interval, which is, as far as I'm aware, is what young Earth creationists think, that the Noachian flood took 1 year to do from beginning to end, we should see this type of class, this rip-up, globally at the base of the flood deposits. Well, we don't. And you cannot go anywhere in the world and point to one stratigraphic continuous horizon and go, yeah, that's where it is, because it does not exist. This is getting unbearably long. And at the very end, I'm going to show you some slides of what caused the Grand Canyon, because you hear me talking about the Grand Canyon, but you don't hear me talking about our actual scientific models of how it happened, because quite honestly, we have several competing hypotheses, and that's fine. That's how science works, all right? But we seem to be going back to a very old idea, which was uplift of the Colorado Plateau is what led to the carving of the Grand Canyon, not the Colorado River cutting down into a bunch of strata. It was uplift. And this would be driven by mantle plumes. And because just to the west of the Colorado Plateau, which is where the Grand Canyon sits, we have something called the Basin and Range. And this is an area of active extension. The continent is getting wider there, and it may or may not rift. So there's something complex going on. Plus, just to the west of that, we've got subduction with transform faults with active rifting. It's a mess. So it's not surprising that there would be some geologic enigmas, all right? But we do have testable hypotheses. Which one is it? I don't know. It might be a mantle-driven thing. It might be a combination. You're going to see some papers that you can look up if you want more detail. How do we know? How can I show you an accurate picture of what's in the Grand Canyon? Well, quite honestly, a lot of people have walked up and down it, climbed it, taken boats down, and they've done the legwork. This here is a geologic map of most of the canyon. It's free online. You can get it. And what you see here, this is how you properly do this. This is taken from the map. There are bits and pieces taken from the map. I have a scale, and the horizontal scale is the same as the horizontal scale in D to D prime on the bottom. D to D prime, when we do a cross section on a geologic map, we say A to A prime, B to B prime, C to C prime for each consecutive cross section. Okay, this is D to D prime. And I selected this one because it's the longest and it shows the most. And there are the approximate rough GPS locations of where D is and D to D prime is. Now there's no vertical exaggeration in this cross section. On the actual map, it is vertically exaggerated 2 times. I reduced its vertical exaggeration to 0 for a couple reasons. One, so it would fit on the slide, and second, so you can see the real topography relative to the cross section. All right, so what do we see here? Well, first here we have this green line. This represents our first great unconformity. Okay, I've just highlighted it there for you so you can see it. The red line here, that is our second great unconformity. The yellow line here, this tiny little connection. Now I'm just taking it from where the left end of that yellow is to the right to D prime. That's just what I'm dealing with. I'm not dealing with the heavily faulted area to the left. Those vertical lines that form Ys and are parallel, nearly vertical, those are faults. I'm not going to get into that area west of Phantom Creek on the cross section, okay? But there's our first and second great unconformity meet in the field, in place, actually on the ground. That is what a good geologic cross-section looks like. If you make a geologic map, you go out there, you pound feet, you take measurements, you look at the rock, you classify it, you analyze it, you do what you need to do so you can figure out the stratigraphy, and then you generate cross-sections to figure out if what you're trying to map is actually correct, or if you've overlooked something. And you can see that the cross section from D to D prime here is really complex. There is no way layer upon layer upon layer upon layer. There have been so many events. Like I said, faults are a type of contact, but they are not unconformities, because faults are events. They're associated with events, and they can be reactivated and stuff. Not necessarily a single instant event like that. It can be over a period of time, but there may or may not be any missing time along a fault plane, because you can get normal faults, which essentially are like this. This would be my fault plane in my two hands. This, or reverse faults where this happens, but then you get strike slip faults where this happens. So strata would be here. This is my fault plane here, and this happens. I'm not going to get, any unconformity. The strata is still in line. Okay, that's why a fault isn't considered a type of unconformity. So I said I wasn't going to do that, but I just explained it to you anyway. But anyway, I think that's it for the Grand Canyon. That's going to be it for this video. It's really long. And I'm going to take you next to Baraboo to show you a buttress unconformity in place. Actually, arguably two. But first I'm going to take you to a classic outcrop, because I need to explain some things to you in order to show you how we recognize these things. Okay? But anyway, that's it. If you have any questions or comments, leave them below, and I hope you learned something.